So the topic is the Springboard caching mechanism. So basically we are covering all the things of caching with respect to Springboard. But before we start mainly on Springboard caching, so I will give some idea on caching, like what are the different definitions of caching. So first of all, like we can say caching can be a temporary memory in the application where all the data are temporarily stored, and those data are not for the permanent. Those data are for some temporary period, like it has some expiry date and it has some limit of storing the data, means it has the caching size. So those are the parameters we need to consider in caching. So now I am going to show you one session outlines of the topics, like what are we are going to cover in these sessions. So we will cover like the topics. First is the what is caching. So inside that we will understand what are the different definitions of caching. After that we will see what is the need of caching, means why we need to use caching in our application. After that we would see what data we should be cached, means what are the types of data need to be cached in the application. Then we will cover types of caching. So basically, uh, there are main four types of caching, like database caching, web server caching, in-memory caching, and CDN caching. And as per Java application architecture, there are three more types of caching, like embedded caching, client server caching, and the distributed caching. You can say this type can be the architectural pattern also, and can be the type also. So then we will learn about Springboard caching process, so which is the main our topic. So after that, we are covering cache annotation, means in order to use the annotations in Springboard application, we need to cover all the annotations like which are used in the Spring application. So we will see each and every annotation and its usages. So after that, we will cover the topic cache providers. So this is the main important thing. So we can connect external cache providers in the Springboard application by different cache providers, and we will see each and every configurations for each of these cache providers and how we can implement those cache providers in our application. Then we will understand about cache configuration. So in this cache configuration, we will understand. So in order to implement uh, caching in our Springboard application, what are the steps we need to follow? What are the configuration steps uh, we need to take on? So those we are understanding in this thing. And at the last, we will go through the practical demo of the caching example. So in the practical demo, we will cover two things. First, we will implement default caching mechanism in the Springboard application. Second, we will implement external cache provider, which is the EH cache. So I will show you both the things in the demo. So before going through the uh, deep in the lines, so let's start with the first topic, which is the what is caching. So you have heard caching in many of the IT areas. So basically, cache is a part of temporary storage, like where your data is temporarily exist, and this caching copies of the local data of your application from the database and stored in the application layer itself. So it is in between your application and the database. Means it is basically used to increase your performance of the application, and the process of storing and accessing data from the cache is called caching generally. So it works on some useful scenarios, like it has some mechanism inside that. First of all, like it stores the recently used data. So it works on some principles. So there are some principles. So let me brief about some of those principles. One of the principles is last frequently used. So last frequently used means that those data which are lastly used, it comes first in the buffer of the cache. Second thing is last frequently used data. Frequently used data means the data which is mostly used in the request. So those data will be captured in the caching area. So those are some principles like how the caching works internally. Basically, when our local system connects to the remote system, so first of all, it gets the data from the database for the first call. And on the subsequent request, it gets the data from the cache. Because in the first call, it will get the data from the database. So at that time, it will copies one copy of data from database to the cache. So on the subsequent request, we will get the data from the cache itself. So it is needed to reduce the performance, because when we hit the database every time with the large request, so the database keeps on loading. So to reduce those things, we are using the caching to minimize the load calculations on the database side. Now our next topic is the why should we use the cache. So there are a few reasons should be considered for using the caching in our application. Basically, it is used to improve the performance of the application. Second, you can say we get the response quickly with the help of caching. And third is the we data which is accessed from cache is always faster than fetching from the database. And also it reduces the costly backend request. So costly backend request means the request which has high latency data. So those should be reduced with the help of caching. So you can say these are some advantages also. So due to that, we are using the caching for that. So now, before we jump to the next topic, let me give you one example. So you have used Amazon or Flipkart, right? So in Amazon or Flipkart, you are searching any product, like say you have added any product in cart, or you have added some products in wish list. So what is happening? So if you are using Facebook or any other social sites, so those advertisements of your products, browser will show you in as advertisement. So it is happening due to caching actually. Means what is happening when you visit the Amazon or Flipkart sites. So browser cache this. So the site will. Our browser will take the cache copy of those data. So when we visit some other sites also, so our browser mechanism is like that. It shows our uh, caching data to the user. Like when you are visiting any of the page, you might see some advertisement of the different things. So those advertisements are coming off your frequently used data. So those frequently used data comes in the form of cache. So the browser are showing that kind of data. So this is the practical example of caching. So there are other usages of the caching. So in this topic, we will cover what are the types of data we can cache. So let's say there are the list of products in e-commerce website. Let's say in Flipkart or Amazon, you have here there are some predefined list of products in the home page. So those products are common to show everyone. So those common products we can easily cache. So the purpose of caching the data is so those are which are common data. Generally, the common data can be cached. Means we cannot make database call for the common data every time. So to capture those things, we are using caching. So next is the data which does not change frequently. Means the data which remains same throughout the request for some of the extent. So that can be considered in the caching. Then I already said this frequently used read queries and read data are the part of the caching. So in short, the data which are frequently used and which are common to show, so those are considered for the caching. And these are the some example purpose. So it depends on the different requirements and our different scenarios of our application. So what is the need of the application? So based on that, we can consider like what data we can kept in the cache. So let's move to the next topic, which is the types of caching. So there are four main types of caching actually. One is the in-memory caching. Second is the database caching. Third is the web server caching. Fourth is the CDN caching. These are the main caching types. And based on architecture, means our Java application architecture, there are further three caching types. First is the embedded caching. Second is the client server caching. Third is the distributed caching. We can also call it as the caching pattern also. So these types are used in the microservice applications generally. So in microservice application, client server and distributed caching, these two are basically used in the microservice architecture. And the embedded caching is used in the standalone application or the simple architectural based application. So let's start with in-memory caching. In-memory caching is a technique like in which your data is stored in the form of RAM or your Java heap memory. So it uses your either your computer memory or it can also use your disk storage also. So those kind of storage technique, we can call it as the in-memory caching. And you have heard these two caching examples, memcache and Redis. These are the examples of in-memory caching. Memcache is a simple one. So it stores the data in string form only. And the Redis can store data in multiple types. It can store data in string, list, set, map. So it can store data in multiple types. So one thing common in caching is that it stores data in the key value pair. That is the common in caching. So basically the key should be either integer or the string mostly, and value can be any type. So next we will cover the database caching. So database caching is the caching mechanism happens inside the database. So in database caching, the caching works on the query which are executed. So those queries we improve our performance of the application by dividing our whole query into the part of the query loads. And also in database caching, we can optimize the performance. We can use different caching levels. So you have here this Hibernate first level cache, which is an example of database caching. And this is the default implementation. So in order to enhance the performance of the database caching, so we can also include second level cache. So the next is web server caching. Web server caching is a mechanism that stores data for reuse. So I have take an example of Amazon and Flipkart. So how they use caching in the browser. So these examples I have already taken for the web server caching. So what is happening, like when a user is visits the web page for the first time, so the data is cached, and when the subsequent request comes to the same page, so it copies it serves a copy of that page in the storage area. Means let's say when user visit for the first time, so the browser will store the copy of that cache page, and when the user visit that page subsequently, so the browser will display it from the caching area itself. So the advantage of is that it will not make query for the second time. Now the next thing is CDN caching. CDN caching, the CDN stands for the content delivery network. So it is the caching which is used in the separate caching servers. So in our application, there are some HTML files, CSS files, images, videos. So those are stored in some separate servers. So those are also added as caching in those storage areas. And in caching servers, so there are multiple instances, and uh, all this storage are divided equally among all the nodes. So serial caching is generally used in the microservice architecture pattern. Now we are jumping into client server caching. So the client server caching means your your caching is placed outside of the application. So as compared to embedded caching, so in embedded caching, the caching itself is a part of the application. But now here caching is a separate server instance, you can say, which is kept out of the application and the database. So in this type of caching, there is a separate cache server which is placed between your application and the database. So what is happening here? So when the request comes from load balancer, so the load balancer get the request and hand over its request to one of your application. Then the application uses its cache client, which call the caching server. So the caching server will looks the data. If the data is found in the cache, so it will return from there. And if the data is not found from there, so it will make the database call and it get the data and populate the data with the cache and return to the user. So it is working in this kind. So this pattern is generally used when we want to share the caching with the multiple applications. So this is the examples client server caching. So next is the distributed caching. So in distributed caching, there can be multiple applications and there can be multiple instances of the cache and there can be multiple nodes inside the caching server. So let me explain how it is working actually. So when the client makes the request to the application, so application will call one of the node of the cache and that node check its instance if that data exists or not in that. If the data is not exist in that particular node, so it will internal communicate with another node. If data is found in any of the node, so the data is returned itself from the cache. If any of the node does not have that data, then only it makes the calls to the database. So the advantage of using distributed cache is that if any of the node server is down or the any instances fail, so the remaining active node will take care of that. So this is the advantage of distributed caching, and your cache and your application and your caching equally share the communication channel. So in this type of caching, the cache is distributed and shared between multiple applications. So this architecture is basically used in microservice. So it minimizes the computation load on the data store. So let me go to the brief. So till now, what we have explained. So we have learned what is caching and what are the different definitions of caching. Then we have covered different types of caching. Uh, in different types of caching. After that, we have covered these architectures, client server architectures, and the distributed architectures. Let me give short brief on like what is the difference between these two architectures. So the only difference is that in client server architecture, there are multiple applications which is shared between this single cache server. But in the distributed caching, there are multiple applications and there are the different caching layers which are shared between each others. So in client server caching, only single caching server can handle multiple requests. But in distributed caching, there are different nodes which can handle the request from different applications. So it is a parallel mechanism and it works in the distributed mechanism. So these are the difference. So now we will come to the Springboard caching. So in Springboard caching, so You can say we are covering embedded caching basically in this Springboard caching. So you can say this Springboard caching as the embedded cache. So when the request comes to the your application, Springboard application, and first and say, and let's say if you have enabled caching in your Springboard application, so Springboard application checks the if the data is available in your cache or not. If your data is available in the cache, so it will return from the cache itself. And let's say if it is not available, it will make a database call and execute the query and get the data. And it's up and it update the data in the cache. So when the request comes again, so it will directly fetch from the cache itself. So at that time, it will not make database call to the database. So this is how the Springboard caching works. So this is the basic internal mechanism like caching is working. So let me explain you some internal things of caching. So for example, if you want to implement caching in your application, you need to consider some strategies. Like there are some parameters you need to take, like in how to define caching in your application. The first thing is you need to define its configuration. So in configuration, you need to define some parameters like its expiry date, means the how much your data should alive in cache. So it had the expiration time of the data. Second, uh, what is the size of the data, means how much we can store in the cache. Secondly, we need to consider one more parameter, eviction policies. Eviction policies, we can say like how the data should be removed. So there are some operations like read through mechanism, write through mechanisms. So means there are some kind of mechanisms like which we need to consider to implement caching in our application. Let me give the one example. When the request come to your application, okay, so it depends on our mechanism, like either to make call in the database first and then update the cache, or 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 directly insert data in the cache and cache will insert the data in the database. So it means the strategy, there are two different strategies, like how we want our application to handle. So this is just an example. So right now, all these things we have considered in terms of Springboard caching only. So in the next, we will see. So let's say I have explained this thing. So in your application, when you have enabled the caching, so application always looks your data in the cache first, then it make the call to the database. If that particular object is not found in the cache, then only it makes access to the database. So it makes the application faster and improve the performance of the application. So now the Spring Boot application provides you the abstraction API. Abstraction API provides all the cache providers and all the cache objects which we can utilize to implement caching. So it works on two things. One is the cache declaration, and second is the cache configuration. Okay. Declaration means what are the methods we need to consider for the cache, and second is the cache configuration. Configuration means what are the configuration needed, and where we can define all this configuration, like to store and copy the data. So these two principles are necessary to utilize caching in our Spring Boot application. So the next is Spring Boot cache annotations. So these are the annotations basically we are going to cover. So first one is the @enable caching. Second is @cacheable. Third is cache put. Fourth, cache evict. Fifth is the caching, and last one is the cache configuration. So first one is the enable caching. So this annotation is a class level annotation. So it is the main annotation which is used to allow caching in our application, or you can say which is used to enable caching in our Spring application. So when you enable caching, so what is happening? It it sets your cache manager, default cache manager in your application, and it creates one in-memory cache using one concurrent hash map. So only if you provide at that enable caching annotation on your Springboard application class, which I have mentioned here. So you can see this is the main Springboard application class, and if we write enable caching here, so it will enable caching mechanism in our application with the default mechanism. So by default, it set up one cache manager and in memory cache using one concurrent hash map. So this is the default caching. So the next is we can also use enable caching annotation on the configuration class also. So let's say if you want to define any cache provider, in that case, you can use enable caching in the configuration class. If you are if you want to use only the default mechanism, then you can use only in the main class. So there are two scenarios. If you want to use default mechanism, you can apply enable caching in the main class. And if you want to implement external cache provider, you can use this annotation at the configuration class level. So apart from adding this annotation, if you want to use external cache providers, you need to register that cache provider with using cache manager. So this is the main configuration annotation, so which is needed. So the next is cacheable. So this is the method level notation. So we can say this is the main annotation which is used to cache the result of the method. So what it does, it caches the response of the method which written by the method. So let's say we have one method, public employee find by ID. Here we are passing integer ID. So in that method, it will return the employee object. So after getting the data, so it will be cached in the caching with the name employees. I have given this employees as the name of the cache. This is the simple cache name we can provide to this class. So the next is attributes. So this annotation has some attributes. So we are going to capture these annotations in detail. So these are cache names, value, key generator, cache manager, conditions, unless. So these are the some annotations I have taken here to explain you some brief on that. So let me explain first, which is the cache name or the cache value. Cache name is simply as per the name. It is used to provide the name of the cache, and the value is also same as cache name. You can say it is the alias for the cache names. So we can use either one of them. So either you can use cache name or the value attributes to define the cache. So you can see here I have defined the same methods, but you can apply in the two ways. In the first one, I have taken cache name is equal to employees, and in the second one, I have taken value is equal to employees. So both are same. You can define in any of the ways. So the next is key. So the key is with which the object can be cached. So let me tell you one thing. So key is used to store the particular data as per the input parameters. So the reason of key is that we can identify each record with specific key. So this is the purpose. We can define key. So let me explain some brief on this key attribute. So the key attribute works on the Spring expression language. Means we have to define with the hash keyword. So let's say here is an example. So I have used the name of the cache in the value, and I have taken key is equal to ID. So this ID, it should match with the input parameter which you are passing here. So what it does, so when the request comes with the ID 1, so it will store the 1 as a key and whatever the value in that particular object which is written by this method. So internally it is stored with the employee's name. Employee name is the name of the cache. Okay, and let's say ID is equal to 1 as the key, and that object which is written by the method is stored in the uh, key value pair. So the next is key generator. So there are some key mechanisms. You can define your own key generation mechanism, means how to generate your own custom key generator. So for that, like you need to define one custom key generator class, and you can define some patterns inside that, like how you can define uh, key name, like let's say ID underscore name underscore like this. If you want to include 2 or more parameters in the key, so to use that, we use the key generator. So let's take an example. Here I have taken the same example and I have written key generator is equal to custom key generator. So here the custom key generator is the name of the class which we are creating externally. So only we need to provide the reference of that key generator in the same class. So it is working in that perspective. So the next, cache manager. So cache manager is the name of the cache manager we need to provide in the attribute cache manager. So in the same way, you need to define your one custom cache manager. And so it is used if you don't want to use the Spring default caching. Means you need to define custom cache manager, and in that custom cache manager class, you can define some configurations like expiration date and some cache size or whatever some other configuration which are needed for caching. You can define in that custom manager class, and you can include this cache manager by the cache manager attributes, and you can provide the name of the class here, custom cache manager. Here, just taken as an example. Next is the condition. Condition is an attribute like which is used for conditional caching. Conditional caching means um, when your data should be cached, there are some conditions we can apply. For example, if your name is less than 10 characters or 20 characters, so it will take the condition inside the cache. So let's say the name is more than 20 characters. So if the name comes with more than 20 characters, will not be cached. So it will only cache the names which has length less than 20. So so I have use the same example, name value as the name of the employees, and you can apply condition equal to hash name dot length less than 20. Here you can see that hash is the Spring expression language, okay, and the name is the parameter which are coming in the method. So it should be same, otherwise the data will not be cached. And we have used length, so it is using the same Spring string convention. So this is the condition you can apply like this. Let's say if you are want to apply not null condition, so you can simply write as hash name not equal to null. So it will only cache the data if the name is not coming null, and if the name is empty or null, so it will not cache the data. So in this way, you can define condition caching in the this annotation. So the next is the unless attribute. So the unless attributes work differently. So it works if certain condition match, and there is one context variable which is provided by the Spring expression language. So basically, this particular attribute works on the result of the method. For example, let's first take an example. Your name argument name has length less than 20. Okay, so it means if your argument is less than 20, so it will not be cached. So here you need to understand the difference. So here the name dot length less than 20, it means if any argument comes with more than 20, so those only should be cached. If it is below 20, it will not be cached. So this condition works opposite to the conditional attribute. In conditional attribute, if the length is less than 20, the data will be cached. But here, if the length of this name parameter less than 20, it will not be cached. It will only cached if it is equals to 20 or greater than 20. Below 20, it will not be cached. So this is the difference between these two attributes. So the next is cache put annotation. So the cache put annotation, it is also method level annotation. So this annotation basically updates the cache before calling the actual method. So in this method, your service method is executed, and whatever the data comes to that return to the method, so those are updated in the cache with the provided name. So let's say I have an employee class and I want to modify my address from address 1 to address 2. So what is happening? So it will first make the database call, and first it updates in the database. So after returning the data from the database, it updates the same data in the caching. So with this attribute means this annotation, we can update the value in the cache with a particular cache name. So the main thing is in every this caching annotations, which are those I have explained, like cacheable and cache put, all these annotations. So you need to provide the name of the cache. Otherwise, you will get some exception and your application will not work in the proper way. So you need to provide the name of the cache. Next is there is one question like, can we use these two annotations on the same method? So the answer is no. The reason is the cacheable annotation will not execute the method if the data is found in the cache. And second, in cache put annotation, the method is always execute, but it will be updated in the cache. Means the method will always execute in the database, and whatever the data comes from the database will be updated in the cache put. So if you are using these annotations together, so the application will not identify. So there will be an ambiguity condition. So whether to follow which condition executes or not. So because if you are trying to use this thing, so your application will not work properly. So and it shows some different behaviors. So it is recommended that these two annotations, cache put and cacheable, cannot be used in the same method. So the next is cache evict. So the cache evict is a method level annotation. Evict means to removal of the data. So it is used to remove the data from the cache. So in the same way, here when the method is annotated with this annotation @cache evict, so your method is executed and the data will be deleted from database as well as from the cache. So means this annotation is basically used for the delete operations actually. So there are two ways to remove the data from the cache. Means you can remove single data by key, or you can remove the whole data of the cache. So you can remove single data as per the key. Means if you are providing particular key, let's say ID equal to 1. So that particular record with having key ID 1 will be removed. And second is the to remove the whole data, there is one parameter, all entries equal to true. So if you are specifying all entries equal to 2, so it will remove all the data, means all the data with all the keys. One thing you should be noted that we should provide the uh, name of the cache, as I said earlier, because if you are not providing the name of the cache, you will get the exceptions, because if you're not providing the name, it will not able to identify which cache to which means which cache to update and which cache should be removed. So the name of the cache is mandatory on the method level annotations. So let me go through revise like what we have learned in quickly. So we have learned here and at the enable caching. So at the enable caching, it's the basic annotations. So it is the main annotation to allow caching in our application. You can apply at two places. One at the Springboard main class if you want to use default caching mechanism, and second you can apply on the configuration class if you want to include external cache providers. Second, we have learned at the rate cacheable annotation. So this annotation is a your cache the data and store in the cache. And these are the some attributes we have learned: cache names, then key, and key generator to define custom key generator, cache manager, which is you should define our own cache manager to write some configurations. Then we have learned about these two annotation attributes, condition and unless. So those are used for conditional caching. So it allows us to cache data when certain condition equals to true. And in the same way, we have learned about this unless attribute. So it works on the result of the data. If your result of the data satisfy the condition, then only it will be cached. So this is the basic difference between these two annotations. So next we have learned this the cache put. So it is used to update the data in the cache. And we have learned about these two attributes, like we cannot use together these two attributes. Then we have learned about this cache evict. It is used to remove the data from the cache. To remove the data from the cache, you can by using single key, or you can delete the whole data with all entries equal to true. So next we are going to cover this annotation at the rate caching. So at the rate caching is nothing but it is combine multiple nested caching annotations on the same method. For example, if you want to use same annotations on the same method of the class, so you can use this at the rate caching annotation, because if you write same annotations on the same method, and Java does not allow to write the same annotations twice in the twice on the method. So to avoid this kind of situation, we are using this annotation. Let's take an example. Here I have used at the rate caching annotation. Inside that I have taken one parameter evict, and inside that I have defined two annotations as a parameter. Like I have defined two evict annotations, one with the key address and one with the key employee. So here we can define in this way. So the next is cache configuration. So cache config is a class level annotation. So in order to define each and every properties to all the methods, so this is the This annotation like provides facility at the class level to define common properties. Common properties can be your cache names, cache manager. So you can define in the class level itself. If you're defining all such common things in the class level, don't need to define at the method level. So let's take an example. Here you can say there is a class employee. Okay. So here I have defined in the class cache name is equal to address. So inside the method, I don't need to define the cache names. So this cache name address will be applicable to all the methods inside this employee class. So you using this annotation, like we can provide common things to the class level directly instead of defining each and everything to the method level. So you can this annotations in that way. So now uh, we are going to learn about some cache providers which are provided by the Springboard. So cache providers basically provide some external configuration which we can integrate with our application explicitly in our application. So to include those cache provided in our application, some configurations are needed. You need to add some libraries in the class path and respective configuration file for that particular class. So let's take first look at the what are the different cache providers supported by the Spring framework. So first is the Jcache. Jcache is nothing but the it is the basic caching API which provides necessary methods uh, for cache configuration which we can use in our application. Next is the simple. Simple is a simple cache provider. So as I already said, if we enable caching annotation in our application, so it by default uses a simple cache provider with one concurrent hash pair. Next is the cache. Cache is a library we can see here. Then there is a Hazel Cache, Infinispan, Couchbase, Redis, and Caffeine. So these all are the different cache providers supported by the Spring framework. So let's understand quickly all this. So Jcache, I already said this is the standard API. So it is provided in this package, javax.cache.spi.caching provider. So if we include this dependency, Spring Boot Starter Cache. So this is the main dependency you need to include in order to enable caching in our Spring application. So this is the main dependency. If you're adding this dependency, it by default provides this API. And then this is the simple I have explained. It is the default implementation. So these two are the default implementations. Means if you are not using any cache provider, these two are by default included as cache providers. So the next is cache. This is the external cache provider. So cache you have here. It is the popular caching technique. So which is widely used in our applications. So it is an open source Java based. So it store your data in memory and the disk. To use this caching, you need some configuration file. So by default, it is called with the name ehcache.xml. So when you add the required dependencies of this cache in the class path, so it will configure this cache manager. So every cache provider has respective cache manager. So for cache manager is the cache manager for that. So if you want to use cache in your application, you need to include this dependency, this org.ehcache. Actually, this dependency is for the ehcache 3.0 version, and for the ehcache 2.x version, there is another dependency. So nowadays, EHCache version 3.0 is widely used. So the next, Hazel Cache. So Hazel Cache is a distributed in memory grid structure. So it is mostly used in distributed application. Means this Hazel Cache technique is generally configured in microservice architecture patterns. So this Hazel Cache has a configuration file. We can define demo file, demo configuration as XML. So it is the configuration file for the cache provider. So one thing is common. Every cache provider has its respective cache manager, and we can provide its configuration in its respective configuration file. Means we can define configuration in two ways. Either you can define configuration in XML file, or you can define configuration in the Java class itself. So all those configuration you can define inside the configuration class, which I have already explained to you. So if you want to use this Hazel Cache, you need to add the following dependency. So by mistake, I have actually there is one another dependency for the Hazel Cache. So the next is the InfiniSpan. So the InfiniSpan is a embedded Java library. So it is the data grid structure. This Hazel Cache is and this InfiniSpan both are the data grid structure. So it stores the value in key value form. And this cache provider does not provide the default file location. So you need to define file location for that manually. So this property you need to define in the application dot properties or application dot YAML file. You need to specify the location of this file, and you need to define the file name. So in order to use this in this cache provider, you need to add this dependency, InfiniSpan core. It is the dependency for this cache provider. Next is Couchbase. Couchbase, you have heard that. So it is a NoSQL database, you all know. So which we can also use as a cache provider also. So it provides support to the Springboard as a cache provider techniques. So it has the respective cache manager, which is Couchbase cache manager. So if we configure Couchbase and add the dependency, which I have mentioned here, so this respective cache manager is configured. So the common thing is every cache provider I have already said has common cache manager, and when we add the dependency, so that cache manager is automatically configured in the application. So next is Redis. Redis, you all have heard that is a popular in-memory data structure. So it is based on key store based pattern. So you can, so it is used as a many ways. It is used in database. You can also use it message broker, queue, or as a cache provider. So Redis is a multiple usages. So it is a popular in-memory data structure which is widely used in our applications. So you need to provide this dependency, Springboard Data Redis, which is the dependency you will needed in order to add Redis in your application. So once you add this dependency, this Redis cache manager is configured in your application, and you can also provide some properties related to Redis with the help of this file properties. So spring.cache.redis dot star. So star you can say you host, and you can define host name inside that. Then there is a port number you can define, and you can also define password, and you can define expiry time to keep, and you can also define some other properties also. So you can define all these properties in application.property file or the YAML application.yaml file. So the next is a cache. So this is a cache provider which is used to provide high performance in your application. So it is used in large applications. So it is basically used in microservice and the distributed application. So it also works on the key value pair store, and it is having in-memory data structure inside that. So if you add the dependency, so it will configure the cache manager, its respective cache manager, which is Caffeine Cache Manager. So we have covered different different cache providers here. So let me go through shortly. So we have covered Jcache, Jcache, which is the basic caching API in the Java library. Then we have learned about simple cache provider, which is by default implemented if you use @enable caching annotation only in the Spring main class. So next is the Cache, which is the open source Java library. Then we have learned about Hazel Cache. Then we have learned about Infinispan, Watchbase, Redis, and then Caffeine. So for all these cache providers, the one common thing is one common thing is its configuration. So now we are jumping into the configuration. So I have summarized all the steps in order to use caching in your application. So this is the basic steps you need to follow. So we are covering here two things. First, we are covering default caching implementation in Springboard application. So for that, you need to follow these three steps. First of all, you need to add this dependency, Springboard starter cache. So this is the main dependency which you need to include in your pom.xml file or in your Gradle also. So this is the main Spring dependency for the caching, whether you are using this default or the cache provider. So next thing is you need to add this annotation @caching in the Springboard main class, which I explained earlier. So without this, your caching will not work. So this is necessary to add in the main class. So the next is @cacheable annotation. You need to add to the method level. So if you add this to the method level, so your result will be cache. So it means these three steps are necessary if you want to configure default caching implementation. So next is if you want to configure cache provider, external cache provider, you need to follow the below steps. So the first step is same. You need to add this main dependency. Then you need to add @caching annotation. But here you need to add this annotation in the configuration class, because in configuration class you can provide some configuration, you can customize some configuration logic there. Means you can use cache manager class and its respective bean properties. So you need to define this annotation in the configuration class. So next is required caching library. So required caching library means what are the dependencies I have shown you for the respective cache providers. So those are the caching libraries you need to include in the class path. Class path means if you define the dependency in pom.xml, so its libraries are available in the class path. So the next is for those respective cache providers, you need to add the separate configuration file. So there are two ways, like either you can add configuration file or you can add Java configuration logic also. You need to write in the configuration class. And the last is the same. You add the cacheable annotation to the method. So these are the two things. So we are going to cover in our practical demo. So first I will show you how to implement default caching, and then I will show you how to implement cache provider. So as a cache provider, I will show you how to configure cache in our Springboard application. So it's time to for practical demo. So in order to save our time, I have defined some necessary things here. So let me show you quickly the project structure. So here you can see this is the Springboard main class, and I have defined address enable caching annotation here. Then I have created one model class. In that I have defined these three properties. Okay. Then I have taken one repository layer, and I am using the JP repository here. So the next is I have taken one controller in which I have defined four methods. Basically, the uh, save, update, get, and delete. So these are the CRUD methods I have defined here. So now let me explain you this service class basically. So you can see here my service class. So I have defined this service class, and I have added this repository here. So I have defined method. One is the save method to save the database, and then this is the main method, get method, on which we have added this annotation, and we are adding uh, this annotation to cache the data. So when the request come here, so this will cache the response of the method. So response is the employee object, and it will uh, store with the key, whatever the key passed here. In the same way, I have provided this cache put annotation on the update method and evict annotation on the delete method. So let me start the application and show you. So our application is started. So let me insert some data. So you can see here, I have inserted three data, and that three data are inserted in the database. Now, let me show you quickly. We are calling this get method and see how caching will work. You will get the idea. So when we hit the request for the first time, so it will call the database. Means it is getting data from the database. So it is executing the service method. You can see the log here. Get this query is executed. So the next is when we hit the same request again. So you can see here the time it is taken in the 21 milliseconds. Before it has taken more than that. So because now the data comes from the cache, and you can see here when I frequently hit this request many times. So though no logs will be generated for the query. So it means the data is comes from the cache itself. So now we are updating the data. So when we update the data, so it will update it in the database as well as in the cache. So let me show you. So if you hit this API, we can see there it will execute the calls in the database for the update operation. So if you are updating data frequently, so it is always make the call. As I have already said, at the rate cache put annotation always make the database call, and it will update the data in the cache. But again executing this get method. So what I have done is, in this method I have updated my address. Okay, so here it is the old one address. So if we again hit this API, so it will update the address. You can see here. So now we are getting this address, updated address, and you can also see there is no get call happening from the database. So now last we are going to delete the data. So when you delete the data, it will execute the query. So data will be deleted from database as well as from the cache. So you can see here the data with the ID is deleted. And so now let me hit this get call again. So you can see here there is a query executed with the ID one, because the data with ID we have deleted, so it is not available in the cache mode. So that's why the database call is made here. So in short, I have explained you this. So how to add default cache mechanism in the Springboard application. So now let me show you quickly one thing. So now we are implementing EH cache as the cache provider. So what we need to do, I will show you quickly. So we simply remove this annotation here at the red caching, and this. So I have the configuration file which I have made already but kept commented. Let me open that. So to use this extra cache provider, we have added this annotation here, and we have defined this cache manager configuration here. So now we need to add the dependencies for that. So let me add the dependencies. So these two dependencies I have already added here. So in this example, we are using EHCache 2.0 version. So for that 2.0 version, we have this dependency. So one thing I need more is this XML file. This XML file I have already created. Now we are using this. This file is, we have defined some configurations like the name of the cache and how much disk size and all, and how much what is the policy. So this is the LFU, least frequently used data. So we are defining the time, expiration time and lifetimes. So all the configuration related to this particular cache we have defined here in the EHCache XML. So let me quickly run the application, show you. So you can see here this log. So this log is generated as we have implemented cache providers. Okay. So we have implemented EHCache. So let me show you quickly. So it is work in the same way which we have seen earlier, but only the difference is we can provide some external configuration in the configuration files, like which I have shown in that XML file. So let's, I added only one record here. So let me get that record from the database. So you can see it is working the same method. It is hitting call for the first time, and we hit the request for the second time. It is not executing. So in the same way, if you update the database, it make the call and update the value. If you frequently update the value, it will not always make calls. So in the same way, if you hit the get API, so you get the updated data here. So
Jitendra, sorry to interrupt. So we have gone about 10 o'clock. So let us try to wrap up now because the people might have
uh,
another meetings as well.
okay, no, I have done from my side.
Yeah,
Nirali. So
okay.
practically is completed. So I have shown everything in the demo. So this is all about caching,
Right.
Nirali. Guys, if you have any questions, you can ask me in the chat. I will give answers in the chat itself.